C30. We're going to just quickly key this up and give you a quick answer key. So the very first one we got to look at here, we have SrCl2. In terms of ions, we look up and we find Sr. And what we're going to find out is that the pen tool I have is too big, so let's make it slightly smaller. And we're going to find out that that is indeed, in fact, strontium. And strontium is a 2+ ion. Chloride is a 2-, or is a 1-, and there's 2 of them. Now, the big important thing here is that strontium can only be 2+, so we do not need to worry about any kind of a Roman numeral to go with that. It is not a polyatomic ion, and this thing is going to be named strontium chloride. Just a smidgen smaller, and it'll even fit on the line. That sounds great. Beautiful. All right. Looking at the next one down, we have Rb and Br, so it's rubidium and bromine. As soon as we look up rubidium on our periodic table, we see that it forms only one ion. That is the Rb+ ion. Bromine is going to form the Br- or the bromine ion. And our name here is going to be rubidium bromide. And then coming up next, we have Na2O. Each of these NAs, and there is 2 of them, has an Na+ charge. The oxygen has an O2-. Again, the important part when I'm looking up these ions here is I'm checking to see, does my metal have the possibility of having more than one ion? And in this case, the answer is no. And so when I name this thing again, is simply going to be sodium oxide. Even though I've looked at my molecular compounds, and if this was molecular, I'd have to use some kind of a prefix for both of these, remembering that this is ionic. I do not need the prefixes, and in fact, they would be wrong. So it would be wrong to say this is disodium monoxide according to the proper IUPAC rules. All right, the next one here, this starts to get slightly more challenging. I have aluminum, and I look on my periodic table. I find out it makes an Al3+ ion. And I have sulfide. I find out on my periodic table that makes an S2- ion. I have 3 and 2. The number that if I start multiplying, that I can multiply 3 by something and 2 by something and get to the same something is 6. And so, or my least common multiple is 6, which means I need 2 of these aluminums. So my formula is going to look like Al2S. And I need 3 of these 2 minuses to get 6 minuses, S3. All right, then I look at my periodic table and I see zinc chloride, and I got to go find the zinc. Oh, there it is, Zn2+. One of the things I should be able to tell without even looking at my periodic table is that there's only one option for zinc because there's no Roman numeral here. Actually, having the Roman numeral makes this just a little bit easier, because if I were to know the formula for, I don't need to look up to find what the, know the symbol, I should say, for zinc. I wouldn't, so when I get down to tin, if I know the symbol for tin, I don't actually have to go look up on my periodic table what the charge is, because the Roman numeral actually tells me the charge. Back to zinc chloride. Each of the zincs is a 2+. Each of my chlorides is a 1-. I look and say I need the same number of pluses and minuses. Well, there's 2 here, which means I need 2 chlorides. So this is going to look like ZnCl2. All right, this takes me on to magnesium iodide. Sorry, I look this up. I find out magnesium is indeed 2+, and iodine makes the iodide anion, which is each of them is an I-. I have 2 pluses. I have 1 minus here, so I need to have 2 of these 1 minus things, and so this is going to be MgI2. All right, when we get to the next one here with cobalt and chloride, I look on my periodic table and I see, in fact, that cobalt, there it is, can either be 2+ or 3+. So now I am going to need to use my Roman numerals. So when I head back over here, I take a look at this and I find out that each of my 2 chlorides are 1-. Means I have a grand total of 2 minuses. So I want to draw both of them out so I can see them. That means that my 1 cobalt needs to give me a 2+, which means when I write my name for this thing, this is going to be cobalt, Roman numeral 2, and it should be actually right next to it, chloride. Right. Come on. Beautiful. All right, so the next one here, I look at titanium, and again, find that on my periodic table. Oops. Titanium, there it is, can either be 4+ or 3+. Now, what does that mean? Oops, wrong button. What that means here is I am going to figure out, is this Roman numeral 4 or Roman numeral 3? So I look up and I say I've got 2 oxygens, and my apologies, when I rebuilt this file, it doesn't quite look like the one, the questions are the same, doesn't quite look like the one out of your workbook. Formatting got messed up. So I have O2- and another O2-. So a total of 4 negatives, which means that titanium has to be 4 pluses. So this is going to be Ti 4+. And as soon as I see that 4+, that tells me it's got to be a Roman numeral 4. So this is going to be titanium, oops, back here, Roman numeral 4, whoa, in brackets, oxide. And there we go. All right, same kind of problem to look at here. When I find copper on my periodic table, if I go the right direction, that'll help too. Copper is going to be, hard to find when it's that big, right here, can either be 2+ or 1+. And so I go back to where I was here. And so the negatively charged ion, that's my key. I have an O with a 2-. That'll never change. Its oxygen's always going to be 2-. And now I have 2 coppers to give me that, which means each of them needs to be just a 1+ charge. And so this then becomes, when I write out the name, copper, Roman numeral 1, because it's a 1+ charge, oxide. All right, tin 2 sulfide. Now this one here, I know the formula for tin, or the symbol for tin, I should say. Zoom in, scroll down. Tin is right here. and it can be 4 plus or 2 plus. That actually doesn't matter because I am given the name. All right, so tin is SN. In this case, I know it is a 2 plus. Oh, I should write this over here. I know the tin is a 2 plus ion. Sulfide is always 2 minus, which tells me I need one of each of them. And this is a weird looking formula, SNS. Looking down here at chromium Roman numeral 3 oxide, I know chromium is going to be a 3 plus version of chromium. There it is. And this is going to be Cr3 plus. Oxide is always going to be a 2 minus. Means I need 2 of these 3 pluses and 3 of these 2 minuses, and then I have 6 pluses and 6 minuses. So this will be Cr2O3. Iron to sulfide. So look at my periodic table. The iron is going to be 2 plus. There's the symbol Fe. So this is going to be an Fe2 plus. And I keep saying that this sulfide is always 2 minus. I can find that on my periodic table too. Here's sulfur. It becomes sulfide, which is a 2 minus charge. S2 minus. And this formula-wise, there's already 2 pluses and 2 minuses, so this is just FeS. What you should notice is actually these two are really the same question. I have to find tin and iron on the periodic table if I don't know what the formulas are, but the work is exactly the same. I have a 2 plus thing and a 2 minus thing, and so there's just going to be one of each. Moving on to number 13 through 25 here. So number 13, I have potassium, and then I look at this and go, yikes, C6H5COO. I should hopefully see that that is a polyatomic ion, and so I got to find C6H5COO. In one way, I guess it's good that it's sort of long. Oops. Zoom in and out for a little bit, see if we can make everybody dizzy. And I kind of go through here and start looking for CH3COO. Oh, not quite. Oh, another COO. There it is. So benzoate, C6H5COO minus. Potassium, that's the K, is only 1 ion charge possible, which means this thing here is quite easy to name. I don't need a Roman numeral, but I do need to know how to spell benzoate, so I know that, but you might have to look it up. Potassium benzoate. All right. Then I have Na2S2O3. I think on your sheet they are all nicely subscripted. So I have sodium, that's the Na part, and S2O3. So we got to find both of those things. As soon as I see S2O3, I know that it is now going to be some kind of a polyatomic ion. Sodium I can see over here. Only one possible charge, so we're good there. S2O3, I kind of scan my way down. Not there, not there, not there, not there, but I see some S's. That looks promising. S2O3 is S2O3 right at the bottom. I suppose I should have started at the back. And it's S2O3 with a 2 minus charge. and that is called thiosulfate. And so I write my name as sodium thiosulfate. If you recall, when we were talking about alternate and weird systems of naming things, that thio part actually tells you that it's like a regular sulfate, which would be SO4, but one of the oxygens has been replaced by a sulfur. All right, moving on, NH4HCO3. And I look at this and go, wow, that's a lot. And then I recognize, hopefully, NH4 is my one weird polyatomic ion that has a positive charge. There's my ammonium. And then I have HCO3. And I kind of scan through. Oh, there it is. So this is going to be ammonium hydrogen carbonate. I can guarantee you this is going to not fit well here. Good thing I don't have to type in the lines. There we go. Next we've got ammonium sulfide. Now these are the slightly harder ones because I actually have to figure out what the formulas are. However, I just looked up ammonium, so I'm going to pretend that I already knew that. This is going to be NH4, and it has a 1+ charge. So ammonium sulfide. Notice that sulfide and sulfite are not the same. Sulfide is just a S and it's 2-. This is not a polyatomic ion. This one is. 1+, 2- is, oh, I need to have 2 pluses, which means I need 2 of these ammoniums. Now I show that there's 2 of them by putting them inside brackets. So we have NH4 and then a little 2 and then an S. NH4, all in brackets, 2 and then an S. All right, then I've got barium sulfite. So I look on here and I find barium. Well, I should find barium if I can see it. There it is. It is 2+. And then I keep looking and I look up here to find sulfite. And I have to be careful. The letters are small. This is sulfate. And then at the top of the last column is sulfite, SO3, 2-. Right, and so what this means here for us, so if I click the right button, I have barium, which is Ba2+. Oops. And sulfite, which is SO3 with a 2- charge. So there's 2 pluses and 2 minuses, so this is actually not a bad one to write. It's just BaSO3. Right, then I've got magnesium hydroxide, which shouldn't have a comma at the end. And so I find magnesium on my periodic table. If I hit the right button, that'll help too. There it is. Mg, it's got a 2+ charge. And then I got to find hydroxide. Kind of scan down to the R, sort of. There it is, hydroxide. OH, and it's just got a 1- charge. So I've got magnesium with 2 pluses, hydroxide with a 1-. I'm going to need 2 of those hydroxides. Right, so I've got Mg with a 2+. And then I've got OH. Each of them has a 1-. And I look at this and go, oh, I got to have 2 of these. Right, so now I have 2 minuses. I have 2 pluses. Everything's happy. This becomes Mg. And then I got to show that there's 2 of these. Now I can't just write MgOH Because that tells me that there's just 2 of the hydrogens, and that's not what I want here. I got to put brackets around to show that I have 2 of the hydroxide, not just 2 of the hydrogens. All right, now we start putting everything together. We're going to add some waters of hydration with the next one. So I've got FeSO4. So Fe is going to be iron. And then this SO4 thing, I got to find that. And iron can be 3+ or 2+. We've already circled that. Let's circle it in another color for a new question. And then I look up here and say SO3. That was my sulfite. No, I need SO4. There it is. And that is sulfate. All right. So this is going to be sulfate as an S. Oops, slow down. O4 2-. And iron can either be 3+ or 2+, but I have 1 iron and 1 sulfate. That sulfate is 2-. That means the iron has to be a 2+, which means I'm going to use a Roman numeral 2. And then I got to find my prefix for the number 7, which is the same as the prefixes we use actually with our molecular compounds. And so it's hepta. And my name of this thing is going to be iron, Roman numeral 2, sulfate, heptahydrate. Because again, it's got that water of hydration. Lovely. All right, so I've got this next one here. I have LiCl. Li, when I find it on my periodic table, there it is. It's lithium. Cl, if we remember from others, is chloride, but there it is. Specifically, there's the ion version of things. Lithium, though, the big thing here is that there's only 1 possible charge. So I know I don't need Roman numerals. So in terms of naming, the first part of this is just going to be lithium chloride. And then I have to find the prefix for 4, which is tetra. And so this thing becomes lithium chloride tetrahydrate. Excellent. All right, looking at the next one here, I have sodium sulfate decahydrate. So I figure out right off the top, deca, okay, that's going to be 10, so it's going to be something dot 10H2O. Anyways, I find sodium on my periodic table. There it is again. I've used it before. It's Na1+. Okay, so no Roman numeral obviously was needed. And I need sulfate. There it is again. SO4 with a 2-. Okay, so again, if I write these out, I've got sodium is a 1+. Sulfate was a 2-. Means that I need, that's supposed to be a plus, not a 4, whatever it looks like. This is why it's a good thing I don't have to write with the mouse all the time. So I have Na plus and I have SO4 2-. So I have 2 Na pluses here is what I'm going to need to balance that out. So this becomes Na2 SO4. And again, I don't need a Roman numeral because sodium only has 1 possible ion charge. So Na2SO4 dot, and this tells me it's decahydrate. Again, that's 10. So 10 H2Os. Lovely. All right, then I've got AuNO33, and it's a solid. That's the little S there. So Au, let's find that on the periodic table. I know off the top of my head that it is gold. But there it is, and I find out, oh no, it can have either a 3 plus or a 1 plus charge. So I'm actually going to have to do a little bit of work with this one. And it was NO3, and there's 3 of those NO3s. So I look here, and it's NH4, nope. No, there's an N, but that's not an NO3. NO3, oh, there it is, NO3. So that's nitrates. It has a 1 minus charge. So I start with the NO3. I have 3 of those. So I know, okay, NO3, oops, with a minus charge. I have 3 of those. So that means I have a total of 3 minuses, which means my 1 AU has to be the 3 plus version of this thing. Right, so this is going to be AU, and it's going to have a 3 plus. Because it's got 3 plus, not the 1 plus, that means it's going to be Roman numeral 3. So this thing is going to be, whoops, not golf, gold, Roman numeral 3, nitrates. There we go. All right. Next one down is bismuth 3 sulfate. That tells me my bismuth, which I can tell you is an oh, that's what's going on. Bi3 plus. Sulfate, we've looked this up before. Do I see it on this page? There it is, SO4 with a 2 minus. Perfect. So SO4 with a 2 minus. Hey, I've got 3 pluses and 2 minuses. I've seen this pattern before. 3 pluses, I'll need 2 of those 3 plus things to make 6 pluses, and I'll need 3 of these 2 minus things to make 6 minuses, which means I'm going to have for a formula Bi2, and then in brackets SO4 3. Beautiful. And then just to be annoying, instead of trihydrate, sometimes they'll be nice to us and write 3 water, which, as the name suggests, is going to mean that it's going to be .3 H2Os. But we have lead, Roman numeral 2 acetate. So we should find lead on our periodic table. Maybe you already know that off the top of your head that it is Pb. We're going to blame Latin for that one. Pipes used to be made out of lead, and plumbers work with pipes. And if you know how to spell the word plumber, P-L-U-M, oh, sorry, plumbing. Let's not worry about a plumber. Plumbing has a B in it. PB comes from lead. Happily, we don't use lead in our pipes. Helps to prevent us from going crazy with lead poisoning, but that's another story. So lead is Pb. This tells me it's going to be the 2 plus version of lead. So Pb 2 plus. It's acetate. And if I start reading down my list here, that's right at the top. Acetate. Lovely. So CH3COO. And it's got a 1 minus charge. So my lead has a 2 plus charge. Acetate is going to be a 1 minus charge, which means I need 2 of these acetates to balance out that lead, which had a 2 plus charge. So this is going to be Pb, and then in brackets, CH, I'm going to run out of space here, 3COO. There's 2 of those, dot 3 waters, 3H2O. Lovely. And finally, we come to the last one here. We have KMNO4. I might look at this and go, hey, wait a minute. KMN, I have potassium, I have manganese, and I have a bunch of oxygens. What's going on here? But MnO4 is a polyatomic ion. So I look on my periodic table and I find out that K is potassium. There it is. It has a 1+ charge. MnO4, I start looking here. Nope. Nope. Oops. Still nope. There it is. MnO4. It is permanganate. Right. And so I have K, which had a 1+ charge. Oh, I should not write that there. K has a 1+ charge. MnO4 has a 1- charge. The most important part here, though, is that K, that potassium, can only have a 1+ charge, so I don't need a Roman numeral. And so I start getting ready to write my name in here, and this is going to be potassium permanganate. Make it so that it fits. Maybe. Beautiful. And there we go. So for those of you who are just looking for answers, let me just try to zoom out a little bit. You can pause it on this screen here. At the very end, maybe, and check your answers. In terms of where are the answers, these three, these three, these three, these three, these three, these three, these two, this one, this one, this one, this one, and this one. Pause it, check them if that's all you're after. Otherwise, if you're in, or if there's one that you need to look at, I went through them in order so you can check it out that way. Thanks.